Hello friends, in this video I'll be explaining DFS by making a DFS tree. So in various problems of graph, like the problem which can be solved by using DFS, the first step will be to form a tree. So with the help of this tree, we'll be able to understand the recursive calls. Okay, so this is a graph, and in my previous video I've already explained DFS using stack data structure. Right now I'll be making a recursive tree. So we can start DFS from any vertex, like either from 0, 1. So I'll be starting from vertex 0 and we'll start traversing this graph and will form a tree. So in order to mark each vertex, we need to make a visited array, and that array will help to know which vertex is already visited. Okay, so let's start. Suppose like this is a root from where I'll start making a tree. So my initial starting vertex is 0. Okay, so from root, like I went to 0. From 0 I can move to vertex 1 or can move to vertex 3. Okay, so like from this root vertex I move to vertex 0, which was my starting vertex. So in visited array, I have marked that my vertex 0 is already visited. Like I have marked it as true. Now from vertex 0, I have two options. Either go to 1 or go to 3. So suppose from vertex 0, I'll be moving to vertex 1. Okay, I'll be moving to vertex 1, mark vertex 1 as true and start exploring vertex 1. Okay, so basically the moment like you are starting from a vertex, the moment you are iterating its adjacent vertex, and if you find any unvisited vertex, then leave the current vertex and start exploring the unvisited vertex. So like the adjacent vertices of 0 are 1 and 3. That's why from 0, like I have two options, like two unvisited vertices, adjacent unvisited vertices are there, that is 1 and 3. So from 0 I can move to 1, or from 0 I can move to 3. So suppose from 0 I move to 1. Okay, therefore I'll leave this 0 and start exploring vertex 1. Now, from vertex 1, the possibilities are 0, 2, 3. Okay, from vertex 1, there are three possibilities, like there are three adjacent vertices. Now, if I move from vertex 1 to 0, so I need to check whether this adjacent vertex is already visited or not. Like, for example, if I move from vertex 1 to 0, I find that 0 is already visited. 0 is already visited. Okay, 0 is already visited. Now from vertex 1, suppose I move to vertex 2. So this vertex 2 is not visited. So leave vertex 1 and start exploring vertex 2. So I'll mark vertex 2 as true. Okay, now from vertex 2, the tree will be like the adjacent vertices are 1 and 4. Okay, 1 and 4. So from 2, suppose I move to vertex 1. In visited array, I will check whether vertex 1 is visited or not. So vertex 1 is already visited. Now I'll iterate and will check for vertex 4. Okay, so vertex 4 is not visited. So what I will do is that I will leave vertex 2 and start exploring vertex 4. So before exploring vertex 4, I'll mark vertex 4 as true. So from vertex 4, the adjacent vertices are 2 and adjacent vertex are 3. I'll check for 2. So vertex 2 is already visited. Okay, vertex 2 is already visited. Now 3. Vertex 3 is already like, okay, vertex 3 is not visited. So from 4, I will move to vertex 3 and start exploring vertex 3. Now, vertex 3, the adjacent vertices are 0 and 4 and 1. So now from 3, I'll go to 0 and in visited array, I'll check. So vertex 0 is already visited. Now I'll go to vertex 1. Vertex 1 already visited. Vertex 4 already visited. So like we have explored all the adjacent vertices of vertex 3. Okay. So what the recursive function will do, it will return back to the caller of vertex 3. So the caller of vertex 3 was vertex 4. And from vertex 4, we have explored all its adjacent vertices. So again, from vertex 4, it will move to the caller of vertex 4. So the caller of vertex 4 was vertex 2. Now, from 2, we have already visited all its adjacent vertices. Like we have visited 1 and 4. So there are no unvisited vertex left from vertex 2. So again, we will move from vertex 2 to the caller of its vertex. So the caller of vertex 2 was vertex 1. Now from vertex 1, we have visited vertex 2. Now we will iterate and check for vertex 3. So vertex 3 is also visited. Okay, vertex 3 is also visited. Like we have already visited vertex 3. So vertex 3 was already visited. So again from vertex 1, there are no more vertices to be explored. So from vertex 1, I'll move to the caller of this vertex, which was vertex 0. So in recursive function, the main thing is like if all the possibilities are exhausted, then return back to the caller of that place, of that cell or of that node. Okay. So vertex 0, like I have exhausted all its possibilities. Like from vertex 0, the adjacent vertices are 1 and 3. So I have like vertex 1 is already visited. Vertex 3 is also already visited. No more possibilities are left. So I'll return back to the root. And finally, the base case will be like if the size of, like if the visited array is having true, like all the cell is being occupied by true, or we will make a count variable which will count like how many vertices are already visited, and we will place this as a base case. Like if our count equals to number of vertices, then return. Okay, so finally we'll be returning back to the main function. Okay, so we'll store this. Either we can directly use print to uh, print it in the output, or we can use any data structure to store this visited vertex. Okay, so for a graph, like there can be more than one DFS pattern. So this is one of the DFS pattern. Like I've started it from vertex 0. Now from root, like we can even start from vertex 1, and again we can make a recursive tree starting from vertex 1. Now again from vertex 2 also we can have a start, and again we'll make a recursive tree.